tall or short, success or failure. So we did mention that specifically our dependent variable has to be categorical and dichotomous. Dichotomous means it has to be measured only on two levels. And those two levels must be mutually exclusive and exhaustive. Meaning it's either you belong to a yes category or you're in the no category. There is no middle ground. There is no neutral ground. So you need only two outcomes. We did mention the fact that the independent variable can either be continuous or categorical. So continuous variables are usually measured as scale, while the categorical ones could be quantified as either nominal or ordinal variables. Then we looked at some examples of applications such as defaulting on loan payment. It's either you pay your loan or you don't pay. There is no middle ground there. So our outcome variable here is defaulting on loan payment, which is either a yes, signifying you paid, or no. Now, what about some likely predictor variables that could influence an individual's likelihood to pay back a loan? Could be gender, age, income, level of education, religion, years employed, other debts, and so on and so forth. Then we also looked at another application when it comes to university or school admissions. It's either you are admitted or you are not admitted. So these are the response variables. And the independent variables could either be gender, number of high school subject pass, and so on and so forth. We've all applied to institutions before, and we know the various requirements. Those requirements are the independent variables, the predictor variables. They determine the odds of being admitted or not being admitted. So after that, we talked about some of the assumptions that must be satisfied before you proceed to perform a binary logistics regression analysis. I mentioned this earlier. We said the DV has to be categorical and measured dichotomously. And then the IV can either be continuous or categorical. Now, last week, we performed extensive statistical tests on how to test the remaining 4 assumptions. Which one? The first one has to do with the independence of our observations, which we can perform using the Dublin-Watson test. So those who missed that session can actually go back to the videos and the PPT and replicate that. And we did mention that the acceptable limit for the DW test is between 1.50 to 2.50. And then after that, we also examine the fact that there should be a linear relationship between the continuous variables and the log odds or logis transformation of the DVs. We did that also. It is very important. And then we tested multicollinearity using 4 various methods: the tolerance, the variance inflation factor, the condition index, and the popular one, which is looking at the bivariate correlation between a pairwise comparison of the various. So we said that for your tolerance limit, which is actually all you have to do is to learn how to interpret. So if tolerance is less than 0.1, it implies a significant multicollinearity in the data set. Then, so this should be the keynote here. Then we also look at the variance inflation factor, which is 1 over the tolerance limit. And then we said any VIF that is greater than 10 is a strong indication of the existence of multicollinearity within the data set. Then we looked at condition index, and we said condition index is simply the square root of condition number. All these things are computed by the SPSS software, and we demonstrated this last week, so I'm just reviewing it. So we mentioned that condition index can either be equal to 15 or 30. That's according to Kennedy 2003. If your condition index is greater than 15, then you're suspecting the existence of multicollinearity. However, if it is greater than 30, then there's a strong presence of multicollinearity in the data set. Yeah, so we tested all that, and then yeah, we performed all that in SPSS. So if you were not part of the section, you can go back to evaluate that. Then we also discuss how to manage multicollinearity in your data set. So these are some of the remedies you can apply if you notice the existence of multicollinearity in your data set. You can remove one or more independent variables. IV here means independent variables from the data set. You can also decide to combine the IVs linearly, those with significantly high correlations. And the phrase highest correlation is looking at correlation coefficients that are greater or equal to 0.7. A very, very effective way of doing that is also to perform EFA, which is exploratory factor analysis. I think about 2 weeks ago, we discussed how to do that. And we did mention that exploratory factor analysis is a dimensionality reduction technique in which you're able to reduce many factors that are presumed to influence an outcome variable into a smaller or parsimonious set of variables that meaningfully explains the response variable. So you can do that if you have too many independent variables in your model. You can reduce them using this, and then you use the factor scores as your predictor variables. That way you're able to reduce multicollinearity to the BRS minimum. So yeah, we talked about this. You can also increase the sample size, because increasing the sample size also leads to reduction in variance, or you can perform the mean difference on the affected IVs. So we did that, and then we also checked how to detect outliers in our data set. We demonstrated this two-case hinges approach, which has to do with the percentile approach, where you have your F1 and F2, where your F1 is the upper limit of your outliers, and you can calculate that using this formula. And for us to do this, SPSS actually calculates all this for us. The only thing you need to do is to do this simple arithmetics, which you can also do in SPSS using the compute function. So you can check out last week's video, we really covered a lot. And then all you have to look at is your F1 and F2. If your F2 is lower or equal, if any value in your data set is lower or equal to F2, it means that value is an outlier. If any value is either greater or equal to F1, it means that value is also an outlier. So you can check out the video for more explanation on that. After that, we also did this, but we look at the box plot method of identifying our outliers. So today, we are going to perform the actual logistics, binary logistics regression. Given that we all participated in how to check for the assumptions last week, I'm going to go straight to demonstrate how we perform binary logistics regression analysis using SPSS. So we are still using the practice week 2 data set. So please launch your data set. That's week 2's data set. Practice data week 2. That's what we are going to use to demonstrate how to perform binary logistics regression and how to explain the associated output tables. So the essence of this analysis is for us to predict or develop a model that shows us the odds of someone defaulting on loan payment given certain number of predictor variables. So we go to analyze, then we go to regression. Under regression, come to binary logistics. Binary logistics. You click on binary logistics regression, and we demonstrated this last week. Our dependent variable here is the outcome variable, and which must be measured dichotomously, and in this case, defaulting on loan payment. So all you have to do is click on it and move it into the dependent box. Then the next thing we have to do is to move our covariate. The covariate here refers to our IVs. So we have gender, age, level of education, years with current employer, household income, and other debt. That was our model last week, so we are going to stick with it. So these two variables are not included. So you move it in here. Now, here's the thing. Remember, in the design, we said your independent variables can either be continuous variable or categorical variables. Now, if you have categorical IVs in your data set, then there is a need for you to indicate it here. Please, I would like someone to respond. Among these independent variables, gender, age, education, employment, income, do we have any categorical independent variable in the list? Please, I need a response.
Yes, we do. Maybe education.
Thank you very much. We do. Education is categorical. So when you have a categorical independent variable, it then means that you have to click on this categorical box. Then you move it to the categorical covariate. But if you don't have any, you're good to go. But because we are having one categorical covariate here, named level of education, which was measured using ordinal scale, you move it in here. Now, after moving it in, come down to your reference category, click on first, then change so that it's indicated, the change is indicated here. Click on continue. Then the next thing you want to do is options. Now, check the Horstman, let me show goodness of fit. Check this box. Also, check the confidence interval for the exponential beta, that's the odd ratios. We'll get to see that later. Check this box, confidence interval for exponential this, and make sure that you're testing at 95% confidence interval, or as your research design might demand, if it's 90% or 99%, that one is left to you. But generally, we test at 95% in social sciences. So make sure that you, okay, I think that's all. Yeah, that's all. So you can click on continue. If you click on save, now what save does is more like you trying to test for the assumptions of binary logistics regression, which we demonstrated some of this last week. But what it does is that you're going to see the distribution of the residuals and so, but we don't need this right now, so we can just leave it out. The rest, you leave it as it is, and make sure that your method is on enter. Then you click on OK. Once you click on OK, SPSS does the rest for you. And you're going to have, why? What happened to my, oh, please let me do that again. I don't know what happened. Skill file read error. Okay. Oh. Please let me close this and launch my SPSS again. I don't know why it's giving me this error. Open the data set. Where is that? A second, I don't know why it's not launching. Let me just quickly close this using the activity monitor. It's not there. Hmm. Sorry for the inconvenience. I don't know why my SPSS was misbehaving. Okay. So I'm going to replicate the analysis again. So we go to Analyze, Regression, Binary Logistics. And I did mention we move the dependent variable, which we defined last week, to be defaulting on loan payment. Then we move all the independent variables or the covariate into the covariate box. And I mentioned if you have an independent variable that is categorical, you move it here. Then you click on first, you click on change, you continue, you click on options, make sure that this is checked. And then you make sure this is also checked. Then you continue. Then that also make sure this is enter. Then you say okay. Yeah. This time around, it didn't give me any error. So now, for a last section of this of today's training program, we'll be focusing on how to explain the outcomes because you have quite a lot of them. Okay, the dependent variable encoding, that's how you've coded your dependent variable. So no is for defaulting on loan payment and yes for doing so. And this is the categorical variable. The categorical variable in our model is level of education, which is captured at 4 levels, 1, 2, 3, 4, 1, 2, 3, 4, 5, and so on and so forth. This is just telling us how the data has been captured. Now, block 0. Block 0 is simply the output of binary logistics regression and SPSS without including the independent variables. So the output without the inclusion of the what? Independent or predictor variables. So, but what is more important that we need to explain here is block 1, because this is our interest. Now, the omnibus test of model coefficients is a goodness of fit test. So this table is telling us how well our data fits the model. How well the data fits the model. So we would expect the significance value to be what? To be less than 0.05. As we can see here, row 3, we can see that the model has what? 0.000, which is significantly lower than what? The priority value of 0.05. So this actually shows that what? Our data set fits the model accurately. So this test uses a chi-square distribution. Now, the next thing we want to look at is the model summary table. Now, this model summary table is synonymous to the coefficient of determination in normal regression analysis, known as the R-square and then adjusted R-square values. So it simply explains the variability or the variation in the dependent variable that has been explained by the independent variables. But in binary logistics regression, we use Cox and Snell's R-square or Nagelkaki's R-square. This Nagelkaki's R-square value is actually introduced to account for the deficiencies in Cox and Snell's R-square. Now, how you explain this is just like your R-square in normal regression value, you can see that the model explains about 26% of the variability in the odds of someone defaulting on loan if you're using this Nagelkaki's R-square value. But if you're using the Cox and Snell's R-square value, then it means the variability decreases to 17.8%. Excuse me. Yeah, so that is how you explain this. Now, the next thing is we want to look at the Hosmer and Lempschutz test. Now, what does this test do? This test is also a goodness of fit test. Though in this test, we would expect that the test is not significant. We would expect that this test is not significant, meaning we would expect that the significance value is greater than 0.05. If it is greater than 0.05, then it means that there won't be much variation in the observed and then the expected outcomes. Now, you can see that R is not significant here, but this data set was not originally meant for this analysis, just a proxy. So you just pay attention to the interpretations, and if you perform yours, you give the accurate rendering of the outcomes. So what it means is that we would if this test is not significant, meaning if the significant value is greater than 0.05, we would expect the values under the observed and expected columns to be almost equal. But here we can see that there are variations, 70, 68, 60, 65. So it means this test is not significant. But ideally, for you to have a more robust test, when you're running a binary regression analysis, you should expect this to be greater than 0.05. Please have that in mind. But in our case study, the value is not significant. Now, classification table. Now, what the classification table does is simply to give us the sensitivity or the degree of accuracy at which our model suits the data set of is good for prediction. So here, the degree of accuracy is only 77.4, which is quite okay. And the last outcome table here is what we call the variables in the equation. Variables in the equation. Now, the first column here lists all the variables we have used in the regression analysis. Gender, age, level of education, and so on and so forth. Now, the first column here is your B, or your beta coefficient, or the slope. Just as in your normal regression model, that's what you have here. And this is the standard error. And this is the world estimator, which uses a chi-squared distribution of degree 1. And then, of course, what we usually look at when we're explaining our regression tables, we look at the significance of each of the variables. Now, in this model, we can see that only years with current employer and then other debts are significant in the model. Meaning that these two IVs are statistically significant in predicting the odds of an individual defaulting on loan payment or not. And then the next thing is we look at the exponential B, which is actually the odds ratio, which is also very, very important. But before I explain that, I would like us to have a theoretical understanding of that. I'm coming. Okay, we've run that. I think I've talked about this. Omnibus test uses chi-square to test how well the data fits the model. Then the model summary table explains the variance in the, that's your Cox and Snell's R square and the other one. Then I explain Hosmer-Lemisch's test, which is also a goodness of fit test. But in this case, your p-value must be greater than 0.05 for significance. Yeah. And I talked about this. Then classification table gives the degree of accuracy. Now, I think I was talking about the odds ratio, yeah. Now, the odds ratio, which is denoted as exponential B in the variables in the equation table, describes the ratio. This describes the ratio. Sorry. This describes the probability or the odd. Let's call it odd, not probability. This describes the odds of an event occurring or not. Now, if odds ratio equals to 1, this is the interpretation, please, very important. If odds ratio equals to 1, then the odds of the model falling into the target group equals to the odd of falling into the non-target group. This simply implies that our model is not significant if there's a 50-50 chance. Now, if the odds ratio is greater than 1, then there is a chance of the event occurring. But if the odd ratio is less than 1, then the odd of the event occurring decreases. So greater than 1, less than 1. So whenever you're looking at your odds ratios, just keep in mind which one is greater than 1. If it's greater than 1, then there's a chance of that, or the odds of that occurring. If it's less than, then it decreases the odds of that occurring. So the most important thing to bear in mind is greater than 1 and then less than 1. So let's go back to our output and quickly explain that. Where's that outcome? Oh, don't close it. How is it not showing? Okay. Okay, so we are here. So now let's take a look at the exponential B column, which is the odds ratio. Take, for instance, even though gender is not statistically significant in this model, I just want to explain. Now we can see that here, our odds ratio is less than 1. So meaning that what? A unit increase in the IV decreases the probability of defaulting by what? This value. So when it's less than 1, it means it decreases. But when it's 1, greater than 1, it means what? There's at least here, it means there's 1.15 times 1.15 times or 15% increase in the odds of the events happening, given this level of education. So that's how you explain odds ratio. Now, if you look at the significant ones, let me use that one to explain. Okay, look at this. Years with current employer, statistically significant, and we have the odds ratio to be 0.82. So meaning the odds of defaulting decreases with a decrease in years, because the B coefficient here is what? Negative. With a decrease in the number of years. Now here, other debt in 1,000, this one increases. So 1.35, meaning there's what? At least 1.35 times the odds of this of defaulting on low payment given other debt. In other words, we can say this is what 35% increase in the odd of defaulting in loan payment given the existence of other debt by the debtor.
Why do you call it 35%, please?
But 1.35, this is if
Times 100? How do you get the 35%?
okay.
Maybe if it was like 0.354, then that's, yes, you could get a
Please,
35.
did you get the explanation from the table? The initial table I showed.
Yeah, yeah,
Just
yeah,
take
yeah,
it,
yeah.
just you can make your own independent research, but just take it, okay?
Okay.
That the odds ratio here,
Hmm.
that 0.35 is simply an increase in the chance of that occurring. It's like if you have something like you've invested money and you're told that after 1 year you have 110%. The original capital is 100%, right? So
Yes.
the increment is a 10% on your money. So just use that concept to understand this odds ratio here.
Okay.
Do you get the logic?
Yeah, yeah, yeah.
Yeah, so when you have odd ratios, you interpret the point as percent. That was why initially I said 1.35 times. Yeah. So just look for the ones that are greater than 1. So if you have an odd ratio of, let me say, 1.5, let's say chance of disease, and we are told that someone has an odd ratio of 1.5%, 1.5 of having that disease. What it means is that there's a 50% increase in the odds of the person getting a disease given a certain level of exposure. So odds ratios are not essentially probabilities.
Okay. Makes sense.
Yeah. Do you
Makes
get
sense.
it, please?
Yeah, yeah, yeah. Thank you.
Yeah. Yeah. So that's how you explain the outcomes and of course the confidence intervals. The narrower the confidence interval, the better, of course. So you explain it like how you would explain any other normal confidence interval, given that it is significance. If it's significant means there is no zero in between, meaning you're not moving from minus to a positive value. Because if you're going to move from a negative lower confidence interval to a positive one, it means you're going to have zero in between. So any confidence interval with zero in between is not statistically significant. So that is how we explain our odd ratios and so on and so forth. So this is how we perform binary logistics regression in SPSS. Any question, contribution is welcome. The floor is open for all researchers to contribute because today is the last day. Dr. Kwame. Hello.
Yeah, Dr. Phil. Yes, please.
Yeah, I think that's all that we're covering today from my end. So if we have any questions, contributions, I would like us to open the floor. Any
Okay,
question?
so everyone, yes, so the floor is open for some interaction. So if you have anything, you can bring it up and then we look at it.
Anything, even if it's not like related to the current topic, like the binary regression, linear regression, or we only have to ask based on today's lecture?
Well, I think let's open it to based on the based on the training so far, because this test is actually meant for beginning to intermediate level. So if we are doing some advanced level statistics, I don't think this is a platform for us to discuss it. Something like panel regression and all that, I don't think it's covered here. So I wouldn't want us to delve into that. But anything related to what we've done so far from week 1 to week 5, we are open to discussing that.
Hello.
Yes.
Okay, thank you very much for your nice presentation and knowledge sharing. Um, uh, uh, sorry if though it may not be a part of this one, can we use SPSS to analyze principal component analysis?
Yes.
Okay. Sorry, could you show us if the time allow for us and if you are willing to do?
I don't have the sample data set, but I think it's a very straightforward procedure. You can just do.
I have can I attach for.
Sorry?
I have a sort of a little sort of data. Can I touch for you?
I don't think I want us to demonstrate that now, but all you have to do is to just Google how to do PCA using SPSS, and if you use ChatGPT, you get a step-by-step procedure on how to run it.
Okay.
Yeah. Or you can go to YouTube and type how to perform PCA using SPSS. You get very brief and self-explanatory videos on that. Under factor analysis, we did mention that principal component analysis is one of the extraction methods when you're doing factor analysis. So if you want to have the fundamentals as well, you can go back to, I think that should be a 3rd week video. You can also take a look at it.
Okay.
Yeah. Any other question, please? Or contribute. It doesn't have to be a question. If you have something you want to share with us, we are all researchers, we are all learning. So it's not like someone teaching, no, we are just sharing ideas. Hello? Okay. In the absence of any contribution, any question, Dr. Kwame, I call on you to officially end the SPSS training program.
Oh, okay, Dr. Phil, thank you so much. So the house, we've come to, hello, I think someone is talking.
No, I was saying thank you, Dr. Phil.
Yeah.
Thank you too for participating.
We've come to the 5th week of the program. Initially, we wanted to have like a 6-week long program, but then we realized a lot has been covered and almost done with all that was planned to be covered. And as I said last week, you can't learn everything in a day. It's not possible. So you will need continual practices. Once you've learned the foundations or the basis, the basic ones you have learned, all you have to do is, as you begin to use them for your own work, you begin to get other things to learn in addition to it. As our brother was asking about the PCA, I remember Dr. Phil taught the dimension reduction in the 3rd week. So even if you go to the 3rd week video, you should be able to see it when he was doing the exploratory and then the confirmatory. Because apart from just using and stressing on the very foundation or the intuition behind what this is. So if we don't have any questions so far, we're going to draw the curtain to the training. But please try to practice one models we've not covered in this session. You can't learn all models, so that one is a fact. But once you begin to practice, you'll get to know that, oh, for this data I'm working with, maybe I'm supposed to use this particular model. But because you've already attended a training like this, it will be easier for you to navigate your way around the software. And that is the most important thing. So I want all of us to say a big thank you to Dr. Phil, and we hope God richly blesses him. So let's say a big thank you to him, and then we end the session. So Dr. Phil, thank you so
Yes,
much
Dr.
on
Kwame.
behalf of
I
everyone.
should thank you all for giving me the platform to share
Thank
the
you.
little I
Thank you.
Thank you
Yeah,
all.
thank you so
Thank you. Thank
Uh,
you. I appreciate your
Thank you very
presence.
much.
Without you, this training wouldn't happen. So thank you for participating.
Yeah, thank everyone for being around, and thanks so much to the OOAD team, the OAAD team. This is Organization of African Academic Doctors. If you are an African, you are pursuing a doctoral program, and you are not in any of their groups, kindly reach out to Gideon, OD, and then they will add you to one of the groups. And if you're a master student, also reach out to them. They have a grooming session, and then they will pull you into the grooming session. So let's continue to interact in the group. If someone asks a question in the group and you know it, please take some moment and then help. And we all build ourselves up one way or the other. So thank you so much, and do have a great afternoon. Okay, Gideon has shared his WeChat ID to the chat box, so you can use to add him. So thank you so much, and Gideon,